To learn more about earning college credits with study hall courses, visit gostudyhall.com or click the link in the description. Some of the software we interact with every day has hundreds of thousands of lines of detailed code to accomplish all kinds of tasks. Like Minecraft has over 500,000 lines of code, and Google Chrome, the web browser, has millions. How are they made, since we all know what a struggle it is to write just one line that the computer understands? Why won't you love me? These huge programs are made by teams of people, like developers, project managers, and testers in a collaborative environment with lots of revisions. That means that we can't just be good coders, we have to be good communicators. And if you're chronically online like me, you might be thinking, actually, Sabrina, Stardew Valley was made by just one developer, Concerned Ape. But shh. Concerned Ape is an outlier and should not be counted. Programs are written for computers, and our classes and methods need to be technically correct to make sure that the code compiles and functions correctly. But it's even more important to organize our programs with other humans in mind, including your future self, so they can understand, revise, and build on the code. I'm Sabrina Cruz, and this is Study Hall, Code and Programming for Beginners. Say we have a simple program. Let's figure out what it does. I see that there's the word for, so we have a for loop, and it looks like we're counting up to 50, probably to keep track of how many lasagnas I've eaten this month. Don't tell my doctor. There's also some variable named s that's increasing by 1 with each loop. No idea what that stands for, but that's all I got. And even that was a bit of a slog, because there's no spacing or indentation in the code, which makes it really hard for me, or anyone, to follow the program's logic or know why it was written in the first place. It's kind of a mess. When we're working on any program, we want to write clean code. Clean code is readable and consistent thanks to thoughtful choices about components like indentation, space between characters and lines, and variable names. Even in simple programs, clean code can make a huge difference. Like if we add a little indentation and spacing, the sequence of tasks in this for loop becomes much easier for humans to read and doesn't affect the computer. Let's also make the variable named s more specific to what's happening in our program. Upon closer inspection, it's a looping sum, so our variable can be named loop sum. Both of these programs make equal sense to the computer, and they churn out the same thing, a variable that increments by 1 until it hits 50. But the clean code is way easier to read and understand. Sometimes even the best efforts to write logical code gets lost as programs get bigger and bigger. In that case, we're left with a heaping plate of what some people call spaghetti code. As delicious as spaghetti code may sound, it's a problem for 3 major reasons. First, it's not lasagna. Second, like we've been saying, it's important for our classmates, teachers, and other programmers to easily follow the logic throughout our program. Sharing code is also an incredibly valuable tool for security, research transparency, and helping people build better programs. And it can be a waste of time or just straight up frustrating to entangle somebody else's pile of freshly cooked, al dente, well-sauced noodle. What were we talking about? Code, right. We still haven't had Italian for lunch, which is a tragedy on par with Hamlet. But anyway, third, spaghetti code is hard to recycle and adapt for new versions of our program or future projects. Lots of software continues to evolve over time. Like as of 2023, Google Chrome is on its 114th major version, with countless minor updates in between. As we start to tackle more complex problems, which generally involve longer, more complex programs, we need to make sure that we're writing clean code instead of spaghetti code. A good rule of thumb is to write one useful chunk of code at a time. In other words, we'll only write as many lines of code as we need to do one useful thing in our program. Then we stop and check that the program compiles and outputs what we want. This strategy is called incremental development, and it can be used on all different scales of projects. In fact, lots of large software teams use incremental development at different scales to stay organized and work together over the course of a project. Every team, company, or research group works a little differently, but many of them develop programs in similar incremental stages. Like, take the team behind the latest software and analytics that help one of those huge, super powerful companies run. The development process often begins with a brainstorming and planning stage, where the main goal is to figure out what the program will be. To be successful at this stage, it's important to understand the needs of the team as well as the needs of the intended users of the software. Next is the design stage, which is where the team plans out the details based on their understanding of the goals and requirements. With that design, the team can start working on the first version of the program during the implementation stage, and hopefully they're writing clean code here. They're professionals after all. Then there's the testing or verification stage, where the software is debugged and tested to make sure it meets all of the user requirements. But with bigger software projects, that's not the end of the program. In some cases, there's a maintenance stage, which is when the program is fixed or improved over time. This is where projects like Google Chrome and Minecraft are now. Unless they add a new feature, which kicks off the development cycle all over again. When the fate of the company or the next great innovation depends on the software and information your team provides, having a clear system isn't just efficient, it makes collaboration much clearer. While clear communication can make or break the entire development process of a program, clean code is especially important during the implementation stage. But we're only human, and realistically, we're not going to be writing perfect code on our first try. It's like writing with human words. Drafts are important. So let's say that we're on a team with some other programmers, and we're working on a program that calculates the environmental benefits of biking instead of driving. This program will take some user input of miles biked, the user's average gas mileage in their car, and the average gas price in the user's area. Using the average gas mileage and a simple unit conversion, the program can calculate how many gallons of gas that would have been used for the reported number of miles. Now, according to the US Environmental Protection Agency, 8,887 grams of carbon dioxide gas, or CO2 for short, are emitted per 1 gallon of gas burned. The program will use that value to calculate how much CO2 would have been released if the user drove instead of biked. Now, let's say that I took a week-long vacation to visit my friend in a slightly different part of Toronto. Now, not only do I have work-life balance, I have friends in this hypothetical. Look at me go! Anyway, the point is, I missed the first draft of our program and need to catch up by looking at what my teammates coded. And I gotta say, it's a little spaghetti-like. If we run this code, everything works the way we want it to, but unfortunately, it's really hard to read. The indentation isn't consistent, we have multiple tasks happening in the same line, and the method and variable names are sketchy at best. N and bike could mean a lot of different things. So, let's clean up this code. The first thing we can do to make the program a lot more readable is making sure that we have only one small task happening in every line of code. In other words, every time that there's a semicolon, we want to hit enter and start a new line. Using indentation also adds clarity to our code, kind of like bullet points in an outline or subsection titles in a paper. It's best practice to kind of nest indents and have one indentation for a class, another for a method, another for a loop, and another for a decision. Right now, our code only has one method and one indentation level, with a bunch of scanner inputs and print statements to do different math calculations. We can also use white space between lines to separate methods or tasks within our code. This makes it even easier to read and makes the logic easier to follow. Think of this like separating big ideas into paragraphs as part of an essay. It's already looking better, but there's still more despaghettifying that we can do. The names we chose for our methods and variables should specifically describe what something is or does in the context of the problem. Names of variables should be noun-like, and names of methods should be verb-like. For example, we can rename the variable representing the number of gallons we've saved to gallons saved, a noun. And the method to find that value can be calculate gallons saved, which includes the verb calculate. With method and variable names, we also want to be consistent with the naming convention, such as Pascal case, camel case, and snake case. As you can see, they separate words in different ways, using capital letters or underscores. In this program, and throughout this series, we've been using camel case. And as a finishing touch, we can make our code easier to parse by including spaces between all of the operators, like the multiplication and division symbols, and the variables we're using in each calculation. With all of these edits, our code is decidedly clean. It's much easier to read, and the thread of logic is easier to follow. The team is so lucky to have me. I am a gift. But we could still make things even easier for our future selves by packaging some of these calculations into methods. Every method in a program should only accomplish one task, so we could split our program up into 3 methods. Calculate gallons saved, calculate money saved, or calculate CO2 saved. And remember, we want to pick clear names in camel case for all of them. Structuring our code with methods like this makes it more maintainable, which means it's easier to make future changes. For example, as we continue to build, we might use the money saved method in like 20 different places in our code. If we need to make a change, like converting from US to Canadian dollars, we only have to make the change in the original method for it to be implemented everywhere in our program. The easier our code is to read and understand, the easier it is to know what each specific line does. This makes modifying and debugging, well, still annoying, but a little easier than digging through a pile of spaghetti. If you only take one thing away from this episode, remember that a working program is not enough to be a good team member, even to your future self. We all get lazy sometimes, but Minecraft's code would fall apart if every single variable was named cube. Writing clean code that can be easily read by other humans requires thoughtful formatting and consistency, and big, powerful programs need to be able to evolve over time as the needs of users evolve. Just like each line of code has to work together and build on itself, programmers have to be team players. And that's not just so that individual programs can run. Innovation, transparent and effective research, and solving interdisciplinary problems all depend on being able to share code. And if we can all read our code, maybe we can change the world. If you're enjoying Study Hall, Code and Programming for Beginners, and are interested in taking an online course and earning college credit, visit gostudyhall.com or click on the button to learn more. Thanks for watching, and see you next time.